Hello students, today discussion is about hydrogen. So hydrogen is one of the key element in the universe and it is the first element after the universe formation. But hydrogen is less abundant in our planet Earth, but it has many uses. So in this chapter we are going to discuss about the discovery of hydrogen, the isotopes, its general physical properties, chemical reactions, how it reacts with metals, non-metals, and its uses, everything we will discuss in this chapter. So to start with, students, discovery of hydrogen. Discovery of hydrogen is done by the scientist first, Robert Boyle, in a reaction where he treated iron with sulfuric acid. He got iron sulfate and hydrogen gas. But he was unable to explain the elementary character of hydrogen gas for the further reactions. That was explained by the scientist Henry Cavendish. So he treated hydrogen gas, he synthesized hydrogen gas by treating zinc with hydrochloric acid, and further this hydrogen gas, he tried to burn this hydrogen gas where he synthesized H2O, water. So he explained the elemental character of hydrogen, but the name was given by the scientist Lavoisier. So as hydrogen, hydro means what, students? Hydro means water, gen means generator. So the meaning of hydrogen is water producer, water generator. When it combines with oxygen by burning, it produces H2O. So this is the general brief history. This is the history of hydrogen. So to discuss about its nature and its abundance in the nature, hydrogen is mostly abundant in the nature in the combined form only. In the free state means directly elemental form, hydrogen, H2 gas. So hydrogen gas does not occur in the free state on the planet Earth, it's very less, and very trace quantities it is available on our Earth crust. But majority of the hydrogen is available on the planet Earth in combined state only. Where it is found then? In the combined state. It is found in the combined state in majority plant and animal tissues, as well as in water. Yes or no? What is the formula of water? H2O. That means, students, for one oxygen, how many hydrogens are there? There are 2 hydrogen atoms for one oxygen. So majority of the hydrogen is found in water in the combined form, as well as it is also found in acids. Yes sir, acids release H plus ions, HCl, H2SO4, as well it is also found in bases. Bases release OH minus ions. It contains hydrogen or not? And majority cases it is also available in petrochemicals, petroleum products. Petroleum products means hydrocarbons. That means majority of the hydrogen also available in the nature by combining with carbon. Those compounds, those petroleum products are called as hydrocarbons. Hydrocarbons means hydrogen is present as well as carbon is also present. So this is the available abundance of hydrogen, students. Next, isotopes of hydrogen. So what is the definition of isotope? Isotopes means atoms of elements with same atomic number but different mass number, which means, students, look at these 3 isotopes. Hydrogen has 3 isotopes: protium, deuterium and tritium. Hydrogen contains 1 proton and 1 electron. That is the general normal hydrogen what we are talking about. But sometimes in rare cases it also contains, hydrogen atom also contains 1 proton, 1 electron, along with 1 proton there is 1 excess neutron also. That makes this isotope called as deuterium. If 2 neutrons extra are there, if two neutrons are present, that is called as tritium. Tritium is radioactive, students, and these isotopes are very rare. So whatever the discussion, whatever the physical properties, whatever the chemical reactions we are talking about hydrogen, that is protium only, 1H1. 1 is atomic number and superscript here 1 means mass number. It contains 1 proton and 1 electron only, no neutrons in protium. So the whole abundant element is protium only, students. The most abundant isotope is protium only. So dual nature of hydrogen, right? So hydrogen, students, it can show metallic nature as well as non-metallic nature. What is metallic nature? Ability to lose electrons is called as metallic nature. That means hydrogen can lose electrons, it can become H plus ions like alkali metals, as well as hydrogen can gain 1 electron and it can become H minus ion like halogens. So it can show both metallic nature by losing electrons, it will show non-metallic nature also by gaining 1 electron. So that is what the dual nature of hydrogen, students. But ultimately when it comes to the physical properties of hydrogen, it is non-metal only, it is not a metal. But while considering the chemical reactions and the configuration, it resembles metallic nature. Right, students? Next, general methods of preparations of hydrogen gas. So how can we synthesize hydrogen gas? So from cold water and from the boiling water. So you can see ultimately when metals treated with water, when metals added to water, so what happens? They react with the water and they produce the respective hydroxides and oxides and they release hydrogen gas. Here, look at here, what are the metals are there here which are reacting with cold water? Potassium and sodium. Why? They are highly reactive metals, so they can even react with the cold water. And here with boiled water we have iron or magnesium. They react with this hot water and they produce the respective oxides and hydrogen gas. Look at here, there is one like amalgam is present, Hg, which means mercury. So why mercury is present here? Why? Because students, potassium and sodium, they are explosively reactive. They are highly reactive as well as they are explosively reactive. To reduce the explosiveness, we used to take amalgam, we used to take the alloy of sodium, alloy of potassium with mercury. Otherwise, it is explosively react. But this alloy, it is not explosively react and we can get the hydrogen gas also. So that's why the amalgam is taken here. And ultimately metals react with water, they can displace hydrogen and they produce hydrogen gas and they produce respective hydroxides and oxides. Next, hydrogen gas can also be synthesized from acids and bases, right? So look at here students, potassium metal when it is treated with hydrochloric acid, will get potassium chloride and hydrogen gas. Similarly, when metals, when they are treated with bases, they also produce hydrogen gas. So like Zn plus NaOH produces sodium zincate and hydrogen gas. Aluminium plus potassium hydroxide produces potassium aluminate plus hydrogen gas. Ultimately, metals when they are treated with acids or bases, they produce hydrogen gas. Next, electrolysis of water or electrolysis of water. Electrolysis is a decomposition reaction, students. Decomposition means when a single compound decompose to produce two or more compounds is called as decomposition. And what is this? Electrolytic decomposition. That means this decomposition is carried out in the presence of electricity. Like how does the procedure work? How does it happen? Look at here, look at the reaction. H2O converts decomposed to produce into oxygen gas and hydrogen gas. Look at the whole setup. We have a glass tube which we have two electrodes. One is called as an anode and other one is cathode. What is the charge on anode? The charge on anode is positive. The charge on cathode is negative. So student, this water molecule, if it is electrolyzed, it will be decomposed into H plus ions and O minus 2 ions. These H plus ions, which are the positive ions, where they will deposit? They will deposit at the negative electrode called as cathode. And O negative to O minus 2 ions, oxide ions, which are negative ions, they will be deposited at positive electrode called as anode. So at cathode, students, these H plus ions gains electrons and they produce hydrogen gas. And at anode, O minus 2 ions, they loses electrons and they become oxygen gas. So you can see clearly the yellow part of the diagram, the volume of hydrogen is more. Yes or no? You can see carefully, the volume of hydrogen is more than the oxygen. Why? Why? Because students, in water molecule, 2 volumes of hydrogen combines with 1 volumes of oxygen. That's why even in the synthesis, even in the decomposition also, we'll get extra volume of hydrogen. That's why. So this is a whole electrolytic technique, and the electrolyte is any dilute solutions of hydrochloric acid or sulfuric acid is taken for the exchange of all these ions. So ultimately we can decompose water molecule into oxygen gas and hydrogen gas. So that means water is made from which elements? Hydrogen gas and oxygen gas. So next, physical properties of hydrogen. Pure hydrogen is colorless, odorless, tasteless, and it is a non-poisonous gas also. Look at the solubility. Hydrogen is practically insoluble in water. Yes, right. Why? Because hydrogen is a non-polar covalent bond, students, and it is very, very light. So it is not possible to dissolve hydrogen in water. As well as look at the boiling point. The boiling point is minus 252.5 degrees Celsius. Melting point is minus 259.4 degrees Celsius. That means at minus 252.5 degrees Celsius only, it converts into gas. That means if you want to convert back hydrogen gas into liquid and solid, it's not so easy to do it. It is, very, very impossible. So liquefaction techniques. Liquefaction means conversion of gas into liquid is called as liquefaction or liquefaction. Both are same. Hydrogen is difficult gas to liquefy. Like I said, the same. It has to be transported under pressure in steel cylinders having almost negligible mass of the gas. Hydrogen, students, what is hydrogen? It contains one proton and one electron. Does it have any neutrons? No, no neutrons. In any element in general, the mass of an atom is based on protons and neutrons, students. But hydrogen doesn't have any neutrons. Electron's mass is almost negligible. So the mass of an atom is based on protons only. It has only one proton. So its mass is 1 gram. Hydrogen gas formula is H2. Its mass is 2 grams. It is one of the lightest gas. So next, occlusion of hydrogen. Students, listen carefully. This is also very, very important point. Certain metals like palladium, platinum, cobalt, etc. can absorb large quantities of hydrogen. This adsorption of hydrogen on metal surface is called as occlusion. So this property is used in many organic synthesis reactions, students. It's not absorption, this is adsorption. Adsorption means hydrogen simply attaches on the surface of these least reactive metals. Yes or no? Platinum, palladium, all these are least reactive metals. Why they're used? Why they're used is because, students, these metals are used to weaken the bond between hydrogen and hydrogen. Why? Because, like I already said, majority of what are hydrocarbons? They're all made up of hydrogen only. Yes or no? So in order to synthesize the reaction, definitely we need to break the bonds. So there these metals are used, and there this property is utilized. For example, hydrogenation reaction, conversion of alkenes or alkynes into alkanes. So in that technique also we use nickel or platinum or palladium, where this hydrogen gas struck onto the surface of these metals. So thereby it weakens the bond between hydrogen and hydrogen, and later on they can be added to the carbon atoms. This property is called as occlusion. Next. So chemical properties of hydrogen. Chemical property means like how does it react with other elements? First, combustibility. What is combustion reaction? Burning reaction is called as combustion. So when we try to burn hydrogen, students, what do we get? For example, if you are burning carbon, what will get? Carbon dioxide. If you are burning hydrogen, what will get? Hydrogen oxide, which is nothing but water. Burning hydrogen gets water, students. That's why hydrogen is one of the cleaner fuel. But unfortunately, hydrogen is very least available on our planet Earth surface, atmosphere. So action with litmus, hydrogen is almost neutral to the litmus, students, and action with non-metals like oxygen, chlorine and nitrogen. So hydrogen plus oxygen, you say what is the formula, what is the product? H2 plus O2 gives rise to H2O. H2 plus Cl2 gives rise to HCl, hydrochloric acid, one of the useful chemical in many synthesis reactions, yes or no? And N2, nitrogen gas, hydrogen plus nitrogen, N2 plus 3H2 gives rise to 2NH3, ammonia. Where ammonia is used, students? Fertilizer. Ammonia is used as a fertilizer, one of the main commercial compound in the market. Right, students? Next, action with metals. Metals reacts with hydrogen, like I have already said in the beginning. When hydrogen reacts with metal, what happens, students? Does it loses electrons or gains electrons? It gains electrons and become hydrides. Look at potassium plus hydrogen. What is the formula? KH. And sodium plus hydrogen. What is the formula? NaH. Calcium plus hydrogen gas. What is the formula? CaH2. According to the valencies, we have different ratios in the compounds. So ultimately they produce hydrides, and these hydrides are strongest reducing agents. Next, that's what the reducing property of hydrogen. So metal oxide plus hydrogen will get free metal, that means pure extra metal as well as water. ZnO, zinc oxide plus hydrogen gas. What do we get? Zn plus H2O. In these reactions, hydrogen is used to extract the pure metals also. And why it is acts as a reducing property? What is reducing property, students? These elements can make other compounds to reduce. What is reduce? Removal of oxygen. Hydrogen here reacting with zinc oxide, and what is happening? Oxygen is removed from the zinc oxide or not? That means zinc oxide is undergoing reduction or not? That is what. And H2 is undergoing oxidation. A reducing agent itself undergoes oxidation, but it makes other compounds to undergo reduction, right? So similarly, the same thing happens here, even for CuO, copper oxide plus H2 also. Copper gets reduced and hydrogen gets oxidized. So here H2 acts as reducing agent. Next, hydrogenation reaction. This reaction is very, very important in organic synthesis. Like we already discussed about this reaction. Alkenes are converted into alkanes. Here ethene converted into ethane, students, with the addition of hydrogen gas. In this reaction only we use nickel or platinum or palladium to weaken the bond between hydrogen and hydrogen. So vegetable oils reaction. Next, uses of hydrogen, students. Look at what are the uses we have for this hydrogen. It is used as a fuel. Hydrogen is used as a fuel. But like I said, it is unfortunately the percentage of hydrogen is very less on our planet Earth, but it is one of the highly abundant element in the universe. So it is used as a fuel. It is present in coal gas and water gas. Look at the percentages of hydrogen, 45%, 50% by volume. It produces a large amount of energy and it produces a cleaner, non-polluting fuel. So it's a cleaner fuel, students, and it is also used for cutting and welding purpose also. Why? Because when the flame of hydrogen and oxygen combines together, it produces a temperature of around 2800 degrees Celsius, called as oxyhydrogen flame. It is used for cutting and welding purposes. Why? Because for welding purpose we need to melt the metal or not. So this flame is used, there we use hydrogen. And for meteorological purpose, for weather condition to monitor, we use hydrogen, as well as for the manufacturing of industrial chemicals like HCl, ammonia, urea, whatever, wherever, hydrocarbons, all contains plastics, all contains hydrogen, synthetic fibers, everywhere, PVC, all contains hydrogen along with carbon, students. Next, hydrogenation reaction, like the previous reaction is, this reaction is hydrogenation only, conversion of alkenes, alkynes into alkanes. Next, in the extraction of metal, the same reaction, zinc oxide with plus H2 gives rise to pure zinc metal and water. So in the extraction of metal also hydrogen gas is used. And for making artificial petroleum, so what is artificial petroleum, students? Like where do we get the petrol? In general, we'll get the petroleum, students. Like how the petroleum is made? Petroleum is made from millions of years ago by the dead aquatic animals which were buried deep under the earth for like millions of years ago under high pressures and temperature conditions. So slowly they converted into this petroleum, yes or no? So once all this petroleum was lost, gone, then how can we depend upon, on what basis we can depend upon? So we can also synthesize artificial petrol. Ultimately, what is the composition of petroleum? Carbon and hydrogen. So by taking the crude oil or the coal, and as well as by taking the hydrogen gas at high pressure and temperature conditions, we can also synthesize hydrocarbons which are used as petroleum. What is the formula of petroleum? Petroleum contains many hydrocarbons, not a single compound, like heptane, octane, hexane. All these are petroleum compounds only we can synthesize, but it is pretty much expensive process, students. But so these are all the uses. Many uses are there, but very least abundant element on our planet Earth. So students, I hope you got the clarity. So please subscribe to the channel for more videos. Thank you, students.